All right, so linear combinations of functions. They're called linear combinations because we're either going to be adding or subtracting. We're not going to be raising these functions to a power or anything like that. We're just going to be doing simple combinations of these functions. So what we're going to do when we have 3f of x plus 5g of x, we're just going to replace f of x right here with its expression. So we have 3 times that entire expression. So make sure that you put it in parentheses, plus 5 times the g of x expression. So we put it in its place, again with parentheses around it. And then it's similar to what we were doing in the warm-up there. We just need to apply the appropriate operations. We need to distribute the 3. So we've got 3x squared minus 15x plus 3. And we need to distribute the 5. Now, in this case, it's not, but just as a side note, if that were a minus, I would go ahead and just distribute it as a negative 5. I think that helps people not miss the signs, which is a very common mistake. So if you go ahead and distribute it, if there were a minus there, go ahead and distribute that as a negative 5. It takes care of the minus. And then we just combine it in like terms. So 3x squared minus 15x squared is negative 12x squared. 15x, negative 15x is the only linear term there. And then constants 3 minus 30 is negative 27. Now, the second example that I have there looks different from the first, but it's actually exactly the same thing. Okay? It's just 2 different notations. It tends to throw people off because when you look at it, you think, oh, I'm supposed to go back and multiply everything by an x. Not really. Okay, this is just another way of showing function notation, and it is saying the exact same thing as 2f of x minus g of x. Okay, you're not multiplying everything by an x. There's no distribution there. It's just another way of expressing that function notation. So we handle it exactly the same way that we handled the first example. 2 times the f of x function. This time we do have a minus. It's minus the g of x function, so you have to be incredibly careful here. There's no constant there to distribute, but there is that negative. It's really like there being a negative 1. So you still have to make sure that you distribute that appropriately. Distribute the 2, 2x squared minus 10x plus 2. Distribute the negative. So that becomes a positive 3x squared and a positive 6. 2x squared plus 3x squared is 5x squared. Again, we only have that single linear term of negative 10x, and then 2 plus 6 is 8. Now, C is very, very similar, except instead of having that x there, we have a number. Same thing as what I just explained in B. We are not multiplying everything by negative 1. That is function notation, meaning we are going to evaluate it for negative 1, meaning we're going to plug negative 1 into those functions. Now, there are 2 ways that you can handle this. Some think one way is easier, some think that the other way is easier. I'm going to show you both ways so that you can make the judgment for yourself. Some people like to look at it the way that it's presented. They like to look at it as 3 times g minus f. They will do that part. They will do that linear combination, simplify that, and then plug in negative 1 for the x. Or some people like to look at it this way. 3 times g of negative 1 minus f of negative 1. When you look at it from this perspective, technically, you're plugging in the negative 1 into each function individually, and then doing 3 times your g of -1 answer minus your f of -1 answer. So let me actually do it both ways, because I know just hearing that can be a little confusing. Okay, so let me do it the first way, where I do 3 times g. So my g of x function is -3x squared minus 6. Notice, kind of change the order. The first two, the f function came first. This time the g function is coming first. Minus our f of x function. Okay, so for the moment, I'm just putting that -1 on the back burner. Okay, I'm doing the linear combination first. Okay, distributing the 3, changing my signs for the second expression, and then combining like terms. So we get -10x squared plus 5x minus 19. So that's the linear combination. We're not finished that yet. We haven't dealt with this -1. Again, it's not multiplying by -1 by any means. It is plugging in -1 for our x value. So we get -10 minus 5 minus 19. I don't care what the calculator tells you, -1 squared is +1. If you don't put it in the calculator with parentheses, then it's going to tell you it's -1, but it's supposed to be +1. So what, this is -34? So that's one way to get that answer. Or we can slightly change the notation. We're not changing anything. We're doing the same process. We're just looking at it from this different perspective. We can evaluate g and f first. G of -1, meaning plug in -1 into the g function, get your answer. So we get what? -3 minus 6, -9. F of -1, so plug in -1 into the f of x function. So +1 plus 5 plus 1, so 7. And then we take 3 times our g answer and we subtract our f answer, and look what we get. We get the exact same number. Now, depending on what the functions look like, one of these may be easier than the other. In my opinion, the second method over here on the right, I think is a little bit quicker and easier. But it really is just a matter of personal preference. Now, when we get to the next problem, I think it's actually easier to use the first method as opposed to the second method. We're pretty much doing the same thing, except instead of having a number, instead of having a single number, we've got an expression that we're plugging in. We're plugging in the expression 1 minus 2a. Now, since that expression is the same in both functions, that means that I can use the first method from example C. I can do the linear combination first, simplify my terms as much as I possibly can, and then I only have to plug in that 1 minus 2a once. The reason why I don't want to do it this way, the second way that we just did in example C, is because if I plug 1 minus 2a into both g and f are both quadratic equations. They both have x squared. So if I'm plugging 1 minus 2a in for x, I'm going to have to square that term. And we reminded ourselves in the warm-up that when we square, we call this a binomial, we have to FOIL it out. So we're going to have to FOIL it out in both cases and combine a bunch of like terms, and then we've got to put the two functions together. So that's why, in my opinion, I think it's easier to put the two functions together simplify them as much as we can, because look at what happened when we simplified it in step C, or in example C. When we simplified it, we only have one single quadratic term. We only have to square it once. We're not going to have to square it twice. So I think it's easier to go ahead and do the linear combination first. So let's do that. Negative f plus 4 times g Okay, go ahead and combine those functions. Distribute the negative, distribute the 4, and then combine like terms. Negative 13x squared plus 5x minus 25. So that is the linear combination. That's the negative f plus 4g. I've simplified it as much as I possibly can. I'm not finished because this problem told me that I was supposed to evaluate this at 1 minus 2a. So everywhere I see x, I'm going to replace it with the expression 1 minus 2a. Now, that is going to require that I FOIL it. So 1 minus 4a plus 4a squared. If I multiply 1 minus 2a times itself, if you need to do that in an extra step, if you need to come over here and write down 1 minus 2a times 1 minus 2a and show the actual steps, I have absolutely no problem with that. I would rather you do that and not make a mistake than to try and do it in your head. If you don't feel 100% confident about doing it in your head, do it over to the side and then put your result in the problem. I have no problem with that. I just don't always show it. Okay, distribute 5, and we don't do anything to the negative 25. We got one more distribution step before we can completely combine our like terms. We need to distribute that negative 13. So that gives us negative 13 plus 52a minus 52a squared. I'm going to go ahead and combine the 5 minus 25, get negative 20. And I don't know about you, but I really like everything to be in standard form. I like my highest powered exponent first. Negative 52a squared. 52a minus 10a is 42a. And then negative 13 minus 20 is negative 33. So that one took, obviously,